Today, we interact with computers through a pane of smooth, frictionless glass. Every operating system and app is carefully designed to hide the actual machinery, leaving us with simple taps and colorful buttons. But beneath that glass lies a chaotic, highly complex architecture of raw data and logic gates, constantly routing our demands. In 1989, that glass didn't exist. If you booted up a Magnavox 286 PC, you were staring straight into the machine's naked engine. It had a tiny 40-megabyte hard drive, relied entirely on physical floppy disks, and offered absolutely zero internet access or password protections. When you turned this machine on, you weren't greeted by a friendly desktop or a helpful tutorial. You were met with a blank, uninviting CRT screen and a blinking cursor. The computer did absolutely nothing until you explicitly told it what to do. That extreme friction served as an accidental, elite training ground. Navigating the computer with zero guardrails forced an entire generation of users to think exactly like systems engineers. Take something as simple as playing a video game. In the MS-DOS era, you couldn't double-click a colorful icon to launch Indiana Jones or Captain Comic. Software arrived on stacks of plastic floppy disks. Often, the only information provided was a single word scribbled in pencil on a blank-lined label, with no auto-run features or digital metadata to help you. To find out what was actually on that disk, you were forced to work through the terminal. You inserted the disk, typed out the drive letter, and addressed the physical hardware directly to mount the drive. Looking at this raw terminal menu, users had to blindly hunt through the disk's contents. You would run directory commands like direct to list out the files, sifting through the text until you found the specific .exe or .com file required to trigger the game. By refusing to launch automatically, the 286 required users to manually uncover the launch sequences. Without realizing it, kids were learning the strict hierarchy of operating systems and file networks just to play a game. Manually typing out those complex directory paths and launch commands every single afternoon quickly became tedious. The natural solution to this annoyance was the .bat, or batch script. These small text files allowed a user to chain multiple DOS commands together into a single automated shortcut. Pressing a single key, like 1, executed a cascade of tasks, changing directories and allocating memory in perfect sequence. Users pushed this further, writing custom configuration files on floppy disks that bypass default startup sequences entirely, diverting into custom-built menus. By writing these scripts to avoid typing the same commands over and over, users crossed a critical threshold. They transitioned from consuming software to actively orchestrating operating environments. When those environments broke or a program crashed, a 1990s user couldn't turn to Google or Stack Overflow for a quick solution. There was no online community to ask. That isolation birthed intense curiosity to figure out why a program behaved a certain way. Users would open raw game files in hex editors, peering directly at the binary data the computer was reading. Looking at this hexadecimal code, they noticed patterns. Every executable file started with MZ, the initials of a key MS-DOS architect. Users realized they could locate high score data buried here, manually overwriting those values to inject their own high scores. Overwriting the hex values changed the game's output instantly. It proved that software is simply raw data that responds to whoever controls the code. Fast forward to today. The focus has shifted from a single desktop PC in a bedroom to massive enterprise cloud infrastructure powering the global internet. Modern engineers use terms like continuous integration and Docker containers to describe how they deploy software. But the core structural logic of these systems matches 1989 perfectly. This comparison reveals the exact parallel. Writing a custom floppy boot disk to carefully allocate memory for a specific game uses the exact same architectural thinking as writing a modern deployment pipeline to spin up an isolated cloud server. The magnitude and speed of these deployments have accelerated exponentially, routing millions of data points in fractions of a second. Yet the foundational mindset required to orchestrate this chaos was born in the raw, text-based era of MS-DOS. The Magnavox 286 refused to hide its complexity behind a pane of glass. It forced curious kids to build the precise engineering logic required to automate the modern world.